So, hello fifth form. Just thought I would touch base. I know that your grades are all going to be based on your mocks plus all the improvement you've made since. So be rest assured that I'll put as positive a spin on all of that as I can. But from reading the government guidelines at the moment, it does look like you guys could have the opportunity, if you wished, to take the IGCSE after the summer holidays, so around September time. So some of you may want to, even if you're at university. Now I can just hear Josh now giving me loads of grief about, I can't believe you started off with maths teachers hub. I promise I won't do this every time, but I thought it was just something to get you going. So I would anticipate these questions will take you half an hour, 45 minutes, but see how you get on. So what I've done, I've started off with 8 of the easier questions. These are just higher level. So for these, all I've actually done is give you the questions here, and then on this slide here I've given you the answers. If there are any of those that you're not clear on, please do just email through to me, and I'll just... Now these, 7 questions, because number 3 isn't applicable, are from the tougher 7, 8, 9 questions. So the next slide's going to give you the answers. So have a go at these first of all, and then have a look at the answers. And then what I'm going to do on the slide after that, I'll actually just talk you through the 7, because I think 1 or 2 of them are, are quite challenging. So those are the answers. Okay, so obviously just check if you've got those right, and then the next video, the next slide, I'll just talk you through each of these in turn. So the first one, 2D similarity. So just draw out your 2 triangles, the 2 similar triangles. So ABC, actually I think I've labelled B and C the other wrong way around, never mind. And AED, similarly, I think I've got those labelling wrong, but it makes no difference. So our small triangle has got the, if I got this completely wrong really, never mind. It's the left hand side should be 7. I've gone and called it the right hand side, but it's the same principle. The base is 20, so we can see that looking at the base, our multiplier is 4, because 5 4s are 20. So in order to work out the side for A to E, okay, we've got to multiply AC by 4. So 7 4s are 28. So AE is 28, but read the question, it wants us to calculate the length of CE. So we take our 28 and we take away the 7, which is AC, giving us 21 centimetres. So question 2 here, you just simply got to substitute in n being 6 and n being 12 and deduct the bigger one from the smaller one from the bigger one. So when n is 6, it's 2 lots of 6 squared minus 5 lots of 6, which is 42. When n is 12, it's 288 minus 60, which is 228. 228 take away 42 gives us the 186. And then, as I said before, leave the question 3. That applies to the GCSE, not the IGCSE. Now, question 4 is 3D similarity. So we're told that the surface area ratio of A to B is 80 to 2000. Dividing both by 80, I can see that the area ratio is 1 to 25. Now, remember how you go from the area ratio to the length, the linear ratio, you square root. So you go from area to length, you square root. If you were going then from length to volume, you would cube. So square rooting the 1 and the 25, we get the relationship of 1 to 5. So the scale factor, what you would have to multiply by to get the length of b is you'd have to multiply by 5. So the linear scale factor is 5. Well, question 5, we need to work out the inverse function for f. So we've done a lot of these. So set y being equal to x squared minus 4 and change the subject. So we add 4 to both sides and then square root. And remember, y is something we've artificially introduced. So our inverse function for f is the square root of x plus 4. Now, we've been told to work it out when we pop 5 into this inverse function. So popping 5 in where the x is, 5 add 4 is 9. The square root of 9 is plus or minus 3. Now, question 6. I'm not entirely sure this is in the IGCSE, but it's very useful stuff if you go on to do A-level. So I think it's well worth taking a look at it anyway. So if you've got a circle where the centre is the origin, then the equation of the circle is just x squared plus y squared equals the radius squared. And that's certainly in our IGCSE syllabus. Now, where the centre of the circle is not the origin, you have to use this formula here. So it's x minus x1 all squared plus y minus y1 all squared equals the radius squared, where x1, y1 is the centre of the circle. So just think of x1, y1 like when we use the y minus y1 formula for equation of a straight line. So try and learn that formula there, and then it's just a question of substituting in our x1 of minus 1 and our y1 of 3. So it's x minus minus 1 all squared plus y minus 3 all squared equals the radius 2 squared, which is 4. And obviously x minusing a minus 1 is x plus 1. Now, question 7, this could come up, okay? Now, we're told that the two roots, so the two solutions when you are for this quadratic graph are minus 1, 0, minus 5, 0. So let's just do a quick sketch. So our two solutions, our two roots are minus 1, minus 5. Now, I think we tend to really visit this the other way around, don't we? We often go and factorize and would say y equals, say, x minus 5, x minus 1, and would then conclude that the roots were 5 and 1, okay? Because we just say what solution gives each of the brackets in turn makes them 0. So this is just the other way around, okay? So we're saying when factorized, we must be having x plus 5, x plus 1 to give us the two roots of minus 5, minus 1. Now, that's all well and good, so that gets us most of the way there, but we do have to make sure we have a constant in front that will give us this y-intercept of 10. Now, if we just left k out of it, when x is 0, we would get 5 times 1, which is 5. But we don't want 5, we want 10. So we have to go and pop a 2 in front, okay? So our k equals 2. I don't know why I've said down there where it's 1, that's just rubbish. So k equals 2, okay? So I'll just go over that again once I've corrected it. So k equals 2, okay? Because what we're saying here, we're saying that when y is 10, x is 0. So 10 equals whatever k is multiplied by, we'll substitute 0 in here, we get 5, 0 in here we get 1, 5 times 1 we get 5. So 10 is equal to 5k, so k equals 2, so our final answer is y equals 2 lots of x plus 1, x plus 5. Okay, and then to finish, question 8. So this is transformation of this graph here. So the basic function y equals f of x has the minimum point 5, 1. So what happens when we transform the graph like this? Well, we've got 2 inside the bracket. Now remember, anything inside the bracket affects the x coordinate but does the opposite to what it says on the tin. So we're going to be halving the x coordinate. So we're going to be halving the 5 to get 2.5. Now anything outside the bracket affects the y value and does exactly what you would expect. So we're going to be adding 3 to the y coordinate. The y coordinate was 1 to start. Add 3 to that, we get 4. So our final answer, 2.54.